This word is repel. Let's say that word together. Repel. Repel means to force to move apart. This word is attract. Let's say that together. Attract. Attract means to pull something towards something else. This book is called What Makes a Magnet? It's an informative text that teaches us all about magnets. The author is Franklin M. Brandley because he wrote the words. The illustrator is True Kelly because she drew the pictures. Let's go fishing with a magnet. Put different things in a box, a twig and some tacks, a needle, paper clips, some rubber bands. What else? You can decide. Choose things that are small and light. Next, find a magnet. They come in all different shapes and sizes. What objects would you choose to test to see if they're magnetic? Tie one end of a string around your magnet. Tie the other end to a stick or a pencil. This is your fishing pole. Go fishing in the box. Put the things you catch in a pile. The others will stay in the box. Why does this fishing pole work for this activity? Because we're not really fishing for fish, are we? We're just trying to see what we can catch or what will attract itself to the magnet. Maybe you caught some things, but not the others. There's a reason why only some things stick to the magnet. They have to be made out of the right stuff. Anything you lifted out of the box probably has iron in it. The iron in these different objects is ferromagnetic. Iron is not the only ferromagnetic material, but it is the most common. Can you tell which objects in your fishing expedition probably did not have ferromagnetic material in them? Well, look what's still in the box. The wood and a twig won't stick to a magnet because wood is not ferromagnetic. The rubber and the rubber bands also won't stick to a magnet because it's not ferromagnetic. There's something else about ferromagnetic materials. They can help you make a magnet. Want to try? The mouse is saying, some people think all metals stick to magnets, but that's not quite right. For example, aluminum is a metal and it doesn't stick. Start with a sewing needle. Make sure it can stick to the magnet. Place it on a table. Hold it there with your finger on the needle's eye. Rub one end of the magnet along the needle, moving the magnet from the eye of the needle to the point, not back and forth. Do this about 30 times. Then touch the needle tip to a tack, paper clip, or pin. If the object sticks to the needle, you have a new magnet. The magnetized needle might even be strong enough to pick up a few objects. The stronger a magnet is, the more it can pick up at once. So which do you think would be stronger, your fishing magnet or the needle magnet? If you have them, try testing them out. How could you make an even stronger magnet? No matter which magnet is stronger, both magnets are small. They can fit in your hand. But there are some very large magnets too. In fact, the whole world is a magnet, even though it doesn't look like one. You can't see the Earth's magnetism, but you can make something that shows you it's there, a compass. Here's what you do. Make sure your needle magnet still works. Then you can get 2 small pieces of foam, plastic, or cork. Carefully stick a piece on each end of your needle magnet. Then float the magnetized needle in a bowl of water. The needle will swing around so one end points north, the other end south. Keep the needle in the center of the bowl so that it can swing around on its own. Then turn the needle around. When you let go, the ends will point the same way as before. This happens because the needle magnet reacts to the Earth's magnetism. To finish your compass, put a dot of ink on the north end of the needle. Then think about where the sun sets. Stand facing that way. Keep this book in front of you. Do you think a compass would be good to take on a hike? Why or why not? Well, I think I'd like to take a compass on a hike because I'm not very good at finding out where I am. And a compass would help me recognize which way was north and which way I needed to go to get back home. The ends of the needle magnet point in different directions because they're different from each other. Each end reacts to the earth magnet in its own way. One end will react by moving and facing the north. It's called the magnet's north-seeking pole. And the other end moves and points in the opposite direction, the south. This south-seeking end is called the magnet's south pole. Magnets are strongest at their poles. When you pick things out of your fishing box, they stuck to the ends of the magnet, not in the middle. Poles make magnets work. Magnets make compasses work, and compasses help people find their way around the block or even around the world. Before compasses, people got lost a lot. How were compasses invented? Well, no one really knows the whole story. For sure, it began a long, long time ago. People from different parts of the world knew of this unusual stone. Iron stuck to it. It could be used to make new magnets from iron. And when the stone was used as a spinner, it came to rest with one end facing north and the other one south. This natural magnet stone was important for making compasses. Some compasses were very simple, stones hanging from a thread. They would turn and point kind of like your compass needle. One compass from long ago was called a fish compass. It was used making a magnetized iron shape like a fish, and when they placed it in the bowl of water, the fish would float to the top and line up north to south. Nowadays, sailors, hikers, and pilots use different types of compasses to track where they're going. Compasses help explorers travel the world. They would return home with new ideas, food, and art. So much happened because people were curious about magnets. Where would you need a compass? Lightning. A bolt of lightning has magnetism. Lodestone, the rock, has a lot of iron in it. A lightning strike on the right iron-filled rock can act like lots and lots of magnet strokes all at one time. Scientists are pretty sure that lightning struck all the places where lodestone is found and changed ordinary stone into a magnet stone. Why do you think that lightning can act as lots and lots and lots of magnet strokes? Well, lightning's pretty powerful, right? Now you know a lot about what scientists know about magnetism. Even so, sometimes it still seems magical. After all, it goes through air and water, glass and plastic, walls and tabletops. Enjoy this feeling of wonder. Keep exploring with your magnets like a scientist and see what else you can find out. Let's say this word together. Repel. Repel means to force to move apart. Today, I want you to use the word repel in a sentence of your own. Let's say this word together. Attract. Attract means to pull something towards something else. Today, I want you to use the word attract in a sentence of your own.